Hey guys, we're going to start our last section for this semester. It's about inequalities in two triangles, so kind of like what we were doing in the last chapter with two different triangles together and proving them congruent. We're doing that the same kind of thing, except now with inequalities. There are two theorems that we're going to do. We're not going to prove these theorems in here. We're just going to be given them and given problems that we can work with them. So the first of the two theorems is called the hinge theorem, or SAS inequality. It is said that if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite the larger included angle. So kind of basing off what we did in the last section with larger angles being opposite of the larger side. So if the measure of angle A is greater than the measure of angle X, then BC is greater than YZ. So that's all basically the hinge theorem is. It's basically the SAS, just with inequalities in the middle. That these are congruent, now they're longer, so the other sides are longer. Let's go through a problem where we use this for. Okay, pretty straightforward problem here. We're given two triangles. We have congruent lengths 4, 4, 7, and 7. But the angles that are included, we have angle LMN and angle QPO. LMN is greater than QPO, and they're asking us what inequality relates LN to OQ. So how would you relate LN to OQ? Just make the inequality that Ln is greater than OQ. That's it for this part of the problem. Now that I know that's kind of quick, but we're going to go on, we're going to do lots of examples with this in class. And we're going to go on to the next theorem, which is called the converse of the hinge theorem. Okay, so the converse of the hinge theorem starts off the same. We have two sides of one triangle congruent to two sides of another, and the third sides are not congruent, then the larger included angle is opposite. Then the larger included angle is opposite the longer third side. So it's just the converse of what we had before. So if we're given that in a triangle where the two sides are congruent and BC and Y is greater than YZ, then the measure of angle A is bigger than the measure of angle X. So we're given these two triangles, two sides are congruent, the longer third side, one is bigger than the other, and the side opposite is bigger than the side opposite of the other third side. That's what the converse says for this. Now we're going to go into two different types of problems. First one, we're given to find ranges of possible values for numbers, and the second one where we're going to go through a proof. Okay, they're asking us what is the range of possible values for x in the figure below. We're given two triangles. We're told that the sides are congruent, two sides are congruent, and the included angles we're looking for, and we're told that the opposite side, so this one is 9 and this one is 7, so we have one that's bigger than the other. So this angle must be bigger than this angle. So we're going to set up two different inequality signs for this. The first one we're going to use is the 3x plus 18 is less than 90. We have to have this less than 90 degrees. We minus 18 on both sides, divide by 3, and then get that x is 24. Over here, we have 3x is greater than 0 because the angle has to be at least bigger than 0 degrees in order to be an angle. So whenever you're asked to find ranges of angles and something has to be less than, you're going to start at 0 and go up to whatever the value is. So 3x plus 18 is greater than 0, subtract 18, divide by 3, x is greater than -6. So our range of values will be from bigger than -6, but less than 24. It can't be those numbers either. Okay, so now that we've gone through a problem with the ranges, let's go through the second problem where we're given a given and a proof for these inequalities. Okay, so in this proof, we are given that MON is 80 degrees, and O is the midpoint of LN. And we're asked to show that LM is bigger than MN. So what we need to do is show that angle MON is smaller than angle MOL, and we also need to show that LO is congruent to ON and MO is congruent to MO. So we need to do SAS, but making sure that the angles are not equal. Okay, so from the given information, we know that LO is congruent to ON. Why do we know that? Because of the definition of the midpoint. Then we can show that MOL is 100 degrees. MOL is 100 degrees because MON is 80 degrees, as it says in the given. And that's because it is supplementary. They must add up to be 180 degrees. Then we can show that MO is equal to MO is congruent to MO because of the reflexive property. So now we have side, 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 and the same side here. And then this side is greater than this side. So that means from the hinge theorem that LM is bigger than MN. So we're going through these problems in the same kind of way where we're proving things congruent, but we're not making sure that the triangles are congruent. We're just showing different parts are bigger than the other. So we're using the proof just in a different way. Okay, that's going to be it for this lesson and this chapter. In class, we're going to do a stations activity. We're moving around the room, going to different parts of the room, and working on a problem for only a couple minutes, and then moving on to the next one. So now that we have done this for a unit, my original plan was to do it for only this unit and then see how you guys feel. So I'm going to leave a question at the end of this, and I want you guys to tell me what you want when we start for semester 2. Do you want to continue doing class like this where we are having homework as a video, and in class we are just doing work, doing problems in class? Do you think you guys want that, or would you like to go back to a normal class where we do the lecture in class and we'll have a little bit of time for homework, a little bit of time for practice in class, and some time and some regular homework that you guys normally had in the beginning of the year? So at the very end of the video, I'm going to leave a question for that, and please answer honestly. If you like this, or if you want this, but you maybe want me to do more with it or less with it, let me know. All right, bye bye.